Hi everyone, this is the third example of T15 hashboard. So let's gonna run the test and see what is going on. We have 0 ASIC. We are going to measure the RI signal, which we start with the last chip and we measure it with the zigzag movement. That is at the beginning and end of each domain route. So it's good. So let's follow the RI signal until we found something drop voltage, low voltage. So that is indicate that that chip or component is damaged. Okay, there is low voltage. So let's go back to the last chip in this domain and we have 1.8. So that means that chip is damaged or something else. So looking carefully, I realized that there is an open resistor which does not close the circuit, causing the signal do not pass from here. There is a missing resistor. The thing that I'm going to do, I'm going to use a soldering iron and just make a bypass. And then when everything is gonna be okay, I will replace for a resistor. So if you could take a look more close, everything is good. So let's run the test and see. Nah, it's still 0. Okay, yeah, it's still 0. But anyways, it's really common when you have some number of a chip and you replace a chip and realize when you test again you got 0 ASIC. It's really frustrating, but as you can see, it's really common. So patience is a powerful tool for repairs this thing. Low voltage, so that means that chip is the problem or something else. I mean, so The things that we're going to do is take off the heatsink of that chip, make a visual check. The current from the LDO travels through this track and passes through each chips, which is the same track must be have a slight resistance less than 1 ohm. It's like 0.2 ohm. It's more close to 0 than 1 actually. So let's measure the resistance. It's a little high. Yeah, it's correct. So let's measure the diode in diode mode, the resistance between the test point, and see if the chip had something wrong. Everything is okay. We measure it and everything is okay. So in that case, the problem is the chip. Why is the chip? Because it's dropped to get a low voltage and we can't measure it inside the chip. So the only way that we can do it in this moment is just replace the chip and see if we're gonna get back the voltage. So let's run the test and see what is going on. And we have two ASICs, so we get back the RI signals. So let's focus on chip number 2. Let's measure the test point signal. So BO signal, it's 0. CO, it's super low, 0.5. No, 1.2. Clock signal. All of it is low, so let's replace the chip. So let's wait for result, and boom. Yeah, so in this case we still have a buffer problem, so we're gonna make a pattern test in next video. Yeah.